So now we're going to talk about figuring out the molecular formula, the true formula. It's called the true formula, meaning what actually makes up that compound. Not the lowest, that's what the empirical formula is. That's the lowest ratio of atoms or ions in a particular chemical formula. We want to get the actual true molecular formula. So we're going to have to we have to use the empirical formula, and then we're going to do a simple division problem to calculate the true actual molecular formula. So in order to calculate, in this case we have 3 separate molecules that we're going to calculate their true molecular formula. And the interesting thing about these 3 molecules is that all 3 of them share the same empirical formula, that 1 C for every 2 H and every 1 O, meaning 1 carbon for every 2 hydrogens and every 1 oxygen. So you're saying to yourself, how can they possibly be 3 different molecules if that is their empirical formula? Well, I'm going to show you why. What you need to start with is that empirical formula, because what we're essentially going to do is we're going to take the empirical formula, that empirical formula mass, that molar mass that we like to find, okay, MM for molar mass, and we're going to have to, before we can calculate the true molecular formula, we have to be given the molecular masses. We have to be given the molecular masses. That's meaning you took your substance and you massed it out 1 mole worth, okay, so 1 mole's worth. So this particular molecule, if you massed out 1 mole, it would equal 30 grams. If you took another compound with that empirical formula and you massed it out, it would equal 60 grams per 1 mole. For this one, it's going to weigh 180 grams per that 1 mole. So these are 3 different molecules, all sharing the same empirical formula. So we're going to use each of their molecular masses to calculate their true molecular formula. So our simple division problem is that we're going to take the molecular formula masses that were given, 1, 2, and 3, and you're going to divide by the molar mass of our empirical formula. So first we got to calculate our empirical formula molar mass. So if we do that, we're essentially saying for carbon, we're saying it's 12.01 grams per mole, plus 2 hydrogens, so that's 2 times 1.00 grams per mole, plus 1 oxygen, 16 grams per mole. That gives me the molar mass of my empirical formula, and that equals 30.026 grams per mole. That number goes here. We're going to take this number that we just calculated, and that's going to go at the bottom of every one of these calculations. Okay? So that's the empirical formula that each one of these molecules and their molecular masses have in common. So you take his molecular formula mass, in this case it's 30 grams per mole, and you're going to divide by the empirical formula molar mass. And that's easy. 30 times divided by 30 is going to give you a lovely 1. We're looking for whole numbers. Our goal is to find whole numbers. It's kind of like doing an empirical formula, except this time we're going to use the whole numbers as a multiplier. Okay, hold tight. 60 grams per mole, same empirical formula, molar mass. Round it out, and I believe it should give you a happy number 2. It's double the amount of mass, all right? This molecular mass of this substance divided by that empirical formula molar mass, again, same empirical molar mass, is going to give you 6, right? So we're going to take each of those 6 whole numbers, and for this gentleman who's made up of C's, H's, and O's, this particular molecule also made up of C's, H's, and O's. This particular compound made up of C, H's, and O. Remember, why are they made up of C, H's, and O? Because all 3 of these molecules share that empirical formula. Which is their molecular formula? Let's go back to the calculation where we took their molecular mass and divided it by the empirical formula molar mass. I came up with a whole number of 1. So that means that whole number, I'm going to take that whole number and I'm going to divide it by the subscript of my empirical formula. So for this particular molecular mass with that whole number of 1, his molecular formula is going to be CH2O1. He's going to be exactly the same as his empirical formula. For this particular molecule, we're going to take that whole number 2 and we're going to multiply it by all the subscripts in my empirical formula. So instead of being just like him, he's now going to be C2H4O2. I just simply took the whole number from calculating his molecular mass by the molar mass of the empirical formula. I came up with the number 2 because that's what I was able to classify. That's their relationship, multiplied by the subscript, and now this is the molecular formula of this molecule. And of course, this one being much bigger, look, his mass is 6 times bigger. That means if he's 6 times bigger, there's more mass, more atoms. That means that I've got more carbons, more hydrogens, more oxygens, and that completely makes sense because his formula is C6H12O6. So this is how you determine the molecular formula, by using this particular problem, taking the ratio of the molecular mass you are given, dividing it by the molar mass of the empirical formula, solving for a whole number, using that whole number to multiply the subscripts of the empirical formula, and then that will inform you of your molecular formula.